Hello and welcome back to the vector section of the SQA Higher Maths course. We've just looked at the unit vector in video 1b. So now we're going to have a quick look at the distance formula and some other things from National 5. So the distance formula will give us the distance between 2 points in either 2 or 3 dimensions. And it's given by this rather straightforward formula. So all this basically finds out is the change in the x direction, the change in the y direction, and the change in the z direction. And it is essentially the same as finding the magnitude of a vector. So when we look at position vectors later on, we'll probably find it's easier just to find the magnitude of the vector as opposed to using the distance formula. So personally, guys, I wouldn't be trying to remember this because there is an easier way of doing it, but we'll have a quick look at it anyway. So here we have x1, y1, z1, the first x, y, and z component coordinates. We have x2, y2, and z2, the second x, y, and z coordinates. And then we're just substituting straight into the formula. So 0 subtract -1, 5 subtract 4, -7 subtract 1. Square them all, add them together, and we get the square root of 66 for the distance between these 2 points. And that's it done. So let's have a little look at the rest of the National 5 recap. So if we have vectors a, b, c, d, e, and f, where a equals d, b equals e, and c equals f, then those vectors are equal. So basically vector 3, 4, 5 is the same as vector 3, 4, 5. So 3 to the right, 4 in the y direction, and 5 up. Addition and subtraction of vectors. So again, National 5 recap. You can have a read of this in the notes if you want to go into it a little bit more, but I'm just going to skim over this page. ABC plus DEF is A plus D, B plus E, C plus F, and the same for subtraction. So let's have a look at the examples. So 152 plus -120. So 1 plus -1, 5 plus 2, 2 plus 0. There we go. And U minus V, so 1 minus -1, 5 minus 2, 2 minus 0 for 2, 3, 2. And how could we make that slightly more annoying because it is just National 5 work? Well, introduce a few fractions, because that might catch 1 or 2 of you out. So here, 3/2 minus 3. So I want to change 3 wholes into 6/2. And then we can just go through and subtract. And I'd also change 3 wholes into 15/5 because 5/5 is 1 whole, so therefore 3 wholes would be 15/5. And then we can just go through and find the vector p minus q. And the same for q plus p. We know 3 wholes are 6/2, we know 3 wholes are 15/5, and then we can just add the components together to get the final answer. Multiplication by a scalar, again, National 5, so just a recap for you guys. So here 3v is 3 multiplied by the x, y, and z components, so it'll be 3, 15, -9. -4r is -4 multiplied by the x, y, and z components of vector r, 24, -12, -4. Negative vectors, if that's AB, then the negative of vector AB, instead of going in that direction, roughly northeast, it would go roughly southwest, so we'd call that BA, or the negative of AB. Again, we cover that at National 5. You've got vector U sometimes, which might be going to the right, then negative U would actually go back to the left. And here's something else new, basis vectors, which you'll be using quite a lot. You will get the hang of this quite quickly. I'll just let you guys have a quick look at that. But basically, I goes 1 in the x direction, J goes 1 in the y direction, and K goes 1 in the z direction. So if I have 2, -3, 6, I could write that as 2i minus 3j plus 6k. So it means exactly the same thing, it's just written a slightly different way. We don't need this bit in the middle. So here's a quick example, right? 7, -2, 3 in terms of basis vectors I, j, and k. So 7 in the x direction, so that'd be 7i, minus 2 in the y direction, minus 2j, 3 in the z direction, plus 3k. Now you can have